First thing what I'll do is I'll tell a little bit about, and this is not a sales talk, but I will tell a little bit about what we're doing in Verisure, so you understand the complexity. So I'll really try to keep that to 1 minute. As you all know, we do home alarms, but what we're doing in the company here is we do the hardware and software design, and that's where we're not doing any microservices. But then lead generation, getting the customers, sales and installation. I mean, people going out in the field selling things, all these products, they all go to a central database. We develop those things very specific. Maintenance, detection, monitoring, verification. Of course, when your fire alarm goes, the alarm needs to get into the center, needs to be handled. But more important, if something goes wrong with one of our servers, you still want to get your fire alarm. IT grade, reboot the system, doesn't work for us. Because we can't say to our customer, oh, wait 3 minutes, we will call the fire department after that. Yeah? And customer service and billing, very important, because we need to earn money. So all these systems are very specific, because we're working with a lot of signals. That in itself, I would say we have about 20, 30 applications. Martin is actually IT Ops, so you know exactly how many applications we have. About that. And then there are applications that everybody has under the desk, you know, that server that you're not allowed to switch off because nobody knows what it does. I think we have a few of those as well. On top of that, our services needs to be working in all those countries. And that makes it hard. It is not a technical thing. It's not like we send you a signal, I have an alarm. But then we get a question like, can we watch at the image that the camera made? Yeah, in certain countries, like in Sweden, we first need to try to call you. Then we are allowed to look at the image. Other countries, the process is completely different. How long can we store it? Can we give it to the police? When can we give it to the police? How do we need to store it? All the countries are different. Spain. What don't we sell in Spain? Selling a fire alarm is really hard in Spain. They're not interested. I bought my first home alarm because I wanted to have a fire detector for my children. But in Spain, they're not interested. But then in Norway, we sell these door locks where you can, with your code on your mobile, can open the door. That doesn't sell in Norway. Anybody has a clue why not? Absolutely. They say, we bought a home alarm. Why would we lock the door? Yeah? Cultural difference, legal difference, etc. This makes it very complex for us. So we have a monolithic system. And why do we have that? Now we started small. And when you want to start an alarm company, you buy a system that takes the alarms. You buy probably Honeywell, the equipment, the hardware, what you install in people's houses. You need to have a class 2 facility for doing the alarm operation. And then you need to have a contract with an vakter, how do you say, some safety guards that you send out if there is something. That's all you need. So you start small and you grow and grow and grow. But we have grown to, how much is it? 2.2 million customers. And then you come into problems. Now you have two approaches. You say, oh, now we have a problem. But you also can say, yeah, we have a problem. Because we were successful. And when you're successful means that you outgrew your system. And that's only positive. So what did we do? We said, okay, we need to be more efficient. So management decided we go to microservices. Smart move? Yeah, I think so. But what are microservices? I think that's important. And the name says it all. Small service here, small service there, everything working together. Well, I'm going to say that now in, 4 paragraphs, that takes a key item from what a microservice is. I didn't say it before actually, but interrupt me any moment you want. There's only one stupid question, is a question you don't ask. Great. It's an architectural style. It's not a technology, it's not a language, it's a style. It's completely agnostic to programming language, etc. Yeah? And it is a collection of loosely coupled services. Loosely coupled, if I have one here, I make a change, I don't affect anything there. In a monolith, if I change something here, that starts crashing. If the guys on the left side of the building change something, the guys on the right side are shouting. Or IT ops in the middle in our case. The benefits of doing that is that it improves modularity and it makes it easier to understand and develop and test these services. Does everybody work with software? Everybody developer, tester? Do we have product owners, project managers, CEOs, bank directors? Everybody works with software. How is it the first time you look into somebody else's code base? I mean, I hate it. And then I need to fix a bug, and I go in there, okay, and then and I need to go to this procedure, okay, and then I have an if statement, damn, now I need to follow both branches. Yeah? Big things need a lot of digging. Microservice, they're small. So it's much easier to get an understanding of what the code does. I turn around, he's there with the camera. Testing makes it easier as well, because you have a well-defined interface and you have a decoupled system. So that means that you can test it in isolation, because the side effects you have of the rest of the system is much less. So note here, this is about efficiency, but not efficient from our systems, not cost efficient, efficient of the people. It also allows you to parallelize development. I should not use difficult words. Parallelizes development, allowing its small autonomous teams to develop, deploy, and scale independently. So you don't need to have this big coordination, these big pyramid organizations, where people on the top need to create big architectures and blah, 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 blah. Which is very powerful, which fits really well into agile development, into Scrum teams where you want to have that isolation. When I learned the first time about Scrum, I didn't get it. How can you do that in a monolith? I'll come to that, back to that. It allows you to develop the architecture doing continuous refactoring. Because it is such a small thing, you can refactor that. You can break it apart, you can combine two together. I guess if you go to your manager and says, let's refactor the monolith. Let's make 2 monoliths out of it. What do you think the reaction is? Maybe in 5 years. In my case, I think they would say, there's the door. But yes, everybody's scared of that. A microservice tries to make that simpler. Conclusion. Normally the conclusion you get at the end. But I tend to talk and I never have time in the end, so we'll do it now. So for me the conclusion is, the main reason to go for microservices is to become more agile and to improve performance of your organization. Do not try to use it to improve your system. Latencies will normally be higher, unless you did something already silly. Microservice need to contact another microservice. Don't do it because it is cheaper in hardware. Every microservice runs somewhere, mostly in a container, which has its own operating system, memory, etc. Cost is higher from that perspective. But do it only to improve performance of your organization, become more agile. Is there anybody who wants to challenge that? If nobody wants to challenge that, we're ready. Not Brandon. It's one of our experts in the area.
Well, we have discussed another feature of it, that by breaking it, a monolith into the needs of different parts of the monolith. So it's
Yeah.
much easier to check the needs of a process than a query.
Could you have done that in with other technologies as well?
Yeah, I guess.
Yes. Yeah. It's not wrong. I mean, there are many more reasons why you can use microservices. It makes things easier, scalability, etc. Yeah? I'll come to that. I think I have those slides now. I refactored them, so that's why I have a little cheating style here. So this is what we tell management, or at least what they think. That's why I have a board with spaghetti there, so they can relate to it easier. And my manager said that he would count, he's not here, but he hopes to get a video, he would count the number of times I make jokes about management, and that would affect my salary discussion that's coming up soon. So I promise him I'll make sure I'll make a lot of comments so I'll get a good raise. How would you scale a plate of spaghetti? Yeah, you can buy a bigger plate, bigger irons, and bigger machines, but they're bloody expensive. Yeah? How do you replace if this part of your spaghetti goes bad? I mean, cutting that out and reattach every little piece, it's hard. Flavors. It should be carbonara, or where's the other one? Bolognese, or whatever you want. Although I think my kids would like to have both on one plate. Yeah? But don't try to visualize that. You understand what I mean? You know, you're stuck with one paradigm. Yeah? You can link other languages in there or the operating systems, but it becomes messy. Resilience. If one of the pieces goes bad there, how do you fix that? It affects the whole plate. If there's some fungus growing in there, we throw away the whole stuff. Huh? The solution, management faction, now we talk about cupcakes. That's actually my manager came that up with when he introduced to the group we're going to work with microservices. So then they told me, like, Vincent, you're responsible for cupcakes. But yeah, we can buy a bigger plate. But you see, we can buy more plates, which fits much more on compared to the spaghetti. So nobody here jumping up and I said, yeah, but you said only do it for making things easier and improve the performance of the organization. But this makes it just much easier for us to scale. It makes much easier for us to scale the system, to add things, we don't have to think that much anymore. We just put there a new plate. Yeah? So it helps us. It makes it easier to scale. And you can, absolutely right, you can monitor each of them. You can see how many do we need, how much load do they take, yeah, well-defined area. We can maintain them easy. If we found out that somebody is allergic to chocolate, we can just remove them one by one and put in other ones. It's not like the spaghetti. Flavors, pick what you want. I don't have to explain that. Again, it makes it much easier. If this part of the solution space is easier to do in my favorite language, Erlang, then yeah, you put there a microservice in Erlang. If you like Perl, if you're masochist and you like Perl, then write Perl. Anybody writing Perl here? Professionally? Hobby. Yeah, good. You write it, you don't read it. Good. But you can choose. Resilience, if one of the pieces goes bad, we just remove it, put a new one in there. Fix it. Huh? This, yeah, you could say, technically it's easier, but from a management perspective, this means your organization works much more efficient. Now I'm running out of my slides. But the thing with this is that the moment we start working, at least I start working with these things, I forget why we're doing it. Because we're engineers, we see the technical problems, and they are sexy, and they are nice to tackle, and we forget why we did it. Like, I often forget why I opened the fridge. I wanted to make a sandwich, but I got the beer out of there. I was hungry, but I forgot it. So don't forget why you're doing it. Dare to make mistakes. Dare to make mistakes. We have been taught all the time to be very risk averse in our systems. Again, if I fix something here, I'll break something there. I see a lot of people nodding yes, but there are some people that are... You never had that? You never had that? All the time. That's why we need to do a lot of testing. Any testers here? Yeah? You know exactly what I talk about. You find bugs there where we didn't have any impact. At least in our systems. So, yeah, but don't do that. It's too risky. Don't redesign it. And then when we start to work with the monolith, there's a little bit of different kind of topic, is focus on your service domain. So what a microservice does. If you talk about the monolith, you have this big block of code, but most likely you have also this big, huge database underneath that. And you want to break everything out. One microservice with its own data source. Yeah, you would like to have 50, 100, 500 microservices, but also 200 data sources. And as we mostly are looking at our monolith very data-centric, we want to break that out first. But I recommend to focus on the service domain. Do the data source later. All good and well. You keep presentations, the organization says we go for microservices, you bring them on a very nice kickoff meeting, which was really nice by the way, and then you start working, and after 3 months everybody's forgetting why we're doing it. Everybody's back into different discussions. So what is the discussion you get then? The optimum size of a microservice, how big should it be code-wise? Anybody? How big should the code size of a microservice be? Any idea? 10 lines. As big as it needs to be. Nobody heard the pizza story? Somebody said as much as you could maintain with the team, you can feed with 2 pizzas. Bad luck if you have me in the team. I can pick your 10 designers, which you probably have a pizza left. The whole thing is, there's only one answer. What is the most optimum for your organization? As big as it needs to be? Absolutely. But if it gets too big, if you lose control, break it out. Break it in 2. Brandon told me a story. Was it BBC? The 250. They had a rule 250 lines. Java code, you can decide, say, libraries, etc. If it was bigger than that, they wanted to break it down. But it wasn't necessary. It was just more rule of thumb. If your organization, your setup, allows you to 1,000 lines, go for 1,000 lines. I mean, 1,000-line machine code versus 1,000-line Java code, there's a little bit of difference there. But what's good for you? We're doing this to improve performance, agility. So use that as a test point, as a decision point, sorry. How many microservices do we need? I had heard management, and I was involved myself. How many microservices do we need? Should we set an upper bound? No. Just let it grow. Again, experiment, try to make mistakes. You'll find out what is an optimal size at a certain point. You need a new service, you introduce a new microservice. Introducing a microservice is really cheap. So don't have that discussion. Grow with it. You're starting to look a little bit confused. No? To go to the cloud or not to go to the cloud, that's the question. Cloud services. Who of you is running in the cloud? A few more hands. Yeah, interesting. But this is an important question. Some would say yes, some would say no. My approach is focus first on getting your microservice right. It scales, and make sure that it is agnostic to if it is running on Azure cloud or Amazon cloud or whatever we have nowadays. Don't make it too complex. Because what happens if you move to microservice, breaking down the monolith, go to the cloud, we add complexity to our system. We need to learn another new thing. So here again, make it easy in the beginning. Use the cloud. I would say run some instances of a microservice in the cloud so you know it can run there. So when you need more capacity, you could use it as an emergency emergency capacity increase. But simplify. But like I said, 3 months, that's what we discussed. And we hadn't written a single microservice, which is quite natural. Now, it's quite human to do that. I think every organization does that. But we were aware of that. At least I told management about it as well. But it is still something that's up for discussion. I think I have a meeting next week on this topic. What to break out from the database first? A hot topic as well. I was getting really big. We serve, not all the countries are in one database. It's not that bad. But a number of countries serve in one database. That is not the problem. The problem is that all kinds of data is in the same database. And it's quite nicely partitioned, but the first thing we want to break out. That's not the question. Go to the service layer. Yeah? Nobody remembers why. If you're lucky, what do you think we will be discussing? Conway's law, organizational changes. I'll give you a second to read what's written here. I'm not that smart that I can write such brilliant English. That's why I don't read it out loud, too many complicated words. I copy this from Wikipedia or any other system. But what Conway's law says is that your organization and your architecture should be in sync. If you have a monolith and you start to work with many small teams, then you create, in a way, a little bit of a problem. Because if team A is doing something here and team B is doing something there, then you might affect each other. So we get complex branching strategies, we get rules about who should check in first, and regression testing, etc., etc. So you need to have a much more controlled organization. If you create an organization where one side takes care of the website and the other side's on the database, then you'll see that back into your design. There's a very clear layer between your website, front-end design and your database. But if they say, now we create one team that takes care of the sales and the other teams takes care of customer administration, you will see your system will look like 2 full-stack silos. So when we started the discussion at Verisure on how should our organization look like, we already had introduced something they called Scrumish. But the organization was not like there. So we have now a monolith on this side, and we want to go here with microservices. But we have an organization that was built for the monolith. So what to do? Yeah, the monolith we can break down in one microservice, keep the monolith, break out 1, 2, 20, 50, 500. But for an organization, we can't say, okay, move one person to a Scrum team, push 2, put 10, put 50. So how do you do that? So long meetings with management, and I'm really happy that they, how do you say in English? Bite the bullet, or took the bullet. They decided, like, that's our vision over there. That's the organization, in that direction we're going to build. It's my department, what I mean. So they said, we're going to make Scrum teams. We want to work this way in the future. Vertical full stack responsibility from front end till the data layer, databases, yeah? Instead of this horizontal organization we had before. That means that we are perfectly organized to work with microservices in a Scrum way. But it also means that we are not so well organized to work with the monolith. We need to understand that. I mean, anybody who tells you this is a win-win situation in IT probably has never done anything. Yeah? It's always memory of CPU or latency or throughput or, yeah. So, but management was bold to make that step, and I really like that. It also means now that our designers, we actually have to hold them back. Oh, wait a second. We do this still in a monolith, because that we do in 2 hours. And if you want to break out everything, it takes 2 weeks. We don't have to push them to break things out now and to go microservices. They're going crazy if we don't want them. We want to hold them back. Of course, because it makes their life easier. It's an investment. Any questions on that? Does it sound logical, what I'm telling? Do you see the same problem in your organization?
Just a clarification. So there were this one, one big team that you split up into what, 2, 3, 4
Yeah, what?
teams, or how did you?
Yeah, what we actually had was we had 3 teams, simplified a little bit. One team was taking care of the database and the layer on top of that. And then we had 2 teams which were on an application layer, taking care of a group of users and applications, and another big group of users and applications. So in principle, we had a 2-tier organization there. And we broke that down into a number of teams that have a full stack. And we could do that, of course, because that team that was working with the database, we could distribute them over the different new vertical organizational groups that we have, and they could spread their knowledge about the database to the team, which you need if you still have to do work in the monolith. But it as well helps you to understand how it affects the monolith when you break out things. Does that answer the question? Yeah. Conway law is really important. And it is maybe one of the things that management thinks about the least. Because it's their point where management and understanding of architecture gets together. Performance. I know I wrote there and I didn't know if I wanted to do there. Whenever I get a new requirement in, you need to build this. You need to add this to the system. But it shall perform better than it did in the past. You know that? You have that? Or does your management say, implement this and it can be 5 milliseconds slower? No, it must be faster all the time. But in a monolith, a function call is really fast. But if I have an HTTP call from one microservice to another one, I get a network delay. Now, if it's on the same server, etc., it's rather low. But still, I have a delay there. So you need to be aware of that the performance of your system will be affected. You can catch up on that one by scaling horizontally, so you have much more parallelism in your system. Yeah? That sometimes can mask that. But be aware. There's a performance hit. if you use Java in your microservice, then if your Java code is called just-in-time compilation, yeah, it will perform much worse the first few iterations you have your code going through there than afterwards. Something that in the monolith you see, oh, it's the startup time. But in a microservice, every time in a microservice you have multiple instances of the same service, you could have that problem 5-6 times. Of course, your code size is much smaller, but you're still having there. So do not ignore that part. Reliability. Sounds maybe a bit strange because microservices are much independent, decoupled. So if a microservice instance crashes, there's still a number of running in the rest of the system. But it costs effort to think about that. I've seen people designing like, oh, this microservice using that one, using that one, using that one, and then the FTP server doesn't respond. And the guys up here don't want to think about that. So what do? Take that into account. If you go to a website nowadays, a lot of the website is using microservices to populate the different areas of the website. And what a website, for example, does is like if the shopping cart doesn't work, so the microservice that gives that part of the shopping cart, they still just put their shopping cart there. Because maybe 90% of the customers are not interested at the moment they look at it in a shopping cart. They're just interested in it when they want to check out. Yeah? So you just pretend that works. And you continue. So the system is not affected by reliability issues in that area. But it causes you to think about it. If I look at shoes, sports shoes, then there's always this line like what other people looked at that also looked at the same shoes as I looked at. And if that part of the system doesn't work, you just respond with some hard-coded proposals that were a month old. Yeah? Reliability, multiple layers. System uptime, how can we recover, till user experience, faking data. Now I jump directly into another one. Having a stable monolith is a good starting point. I said to you before, breaking up the service domains is easier than breaking up the data domain. And one of the things that I found out when reading on the net a lot is that companies that start building big microservice systems from the ground up, they are much more likely to fail than those that have a monolith. Why do you think that is? Especially the data domain they have problems with. They must create a data domain breakup because they have nothing. But the ones that have a monolith, they have worked with that. They have refactored their schemas multiple times. So they have a much better knowledge. But still, it's quite difficult to do that, even if you know your domain. Let's say you create a microservice which is taking care of user information, and you have a security microservice that takes care into logging. I say logging, I mean log in logging. If you would create that service first, the in-logging, now I'm mixing Swedish and English. Authentication. Yeah. No, I need to be careful I don't say authorization. Authentication. You could say, but then I store, of course, always hashed with a seed, password, and an email. It's wise choice. Everybody agrees? Yeah, good. My microservice takes care of logging in, authentication, password, email. Then another guy comes and says, now I'm going to write the microservice for all the user information. Name, address, street name, birthday, telephone number, email address. creates a database with all that stuff in there and a microservice. Smart? Sure. Yeah, absolutely. Now somebody creates a website where the user can go in and change his email address. But now I need to change it in that data source with the user information, and in that data source where we have the login information. You see the problem. If you're not careful, there are 5, 6, 7, 8 of those systems. And then you need to keep track on where do I need the updates. And they have very strong coupling into your system. I'm not going to tell you how to break it up. I just give an example how easy it is to fall into the trap to choose the wrong data domain. And this is probably one that you discover really quickly or find out. But you talk in general about much more complex systems. So having a monolith and working from there is much easier because you have already probably these questions. You already have one place you store emails in. And if you're working in a system where you have 10 copies of the same email in different tables, change the company. It will be so much easier. I'm not saying we don't have data duplication in the system. Yeah? Brandon?
I just want to ask you if you're actually arguing that normalized data models are most appropriate always, or if what you're actually arguing for is that if you're moving to a denormalized data model as part of your breaking up of the monolith, starting with a normalized data model will help you understand your write pattern.
Yes. Yeah. It's never black and white. It's never black and white. And I'm not going to go into the details here. And you understood, I mean, I know Brandon pretty well. And I actually learned most, if I say something smart, it's because he told me once. If it's something stupid, it's because I hadn't asked him. Yeah? Data is really difficult. You will not. You come into play into questions like, okay. No, let me say a different way. I avoid the question a little bit, but I go a little bit more into what to do with data. Because you're having all the microservices, then you're going into a situation where you sometimes would like to have a caching or a temporary copy or something, or you have some duplication, which is absolutely right as long as you know what you're doing. Yeah? But the moment you have copies of data, then you need to say there's one single source of truth. That is where where the truth is. That is where we go back to. Then it's quite okay for let's say telephone number. It's quite okay to have somewhere a copy of a telephone number which is 10 minutes old, because the risk that it brings you into problems is not an issue. Yeah? You can also do replication on the data source layer that's all not a problem. But you need to be aware of that. You need to be aware that you do that. You need to be aware, like, what is your source, single source of truth? What is I tend to use the dirty copy, or where you do your dirty reads. And then you have the content. What Bren as well always talks about is a critical read. When, let's say, we're creating a document management system or an article publishing on the web, I think it's called CMS. If I'm writing the article, I publish it to the website, or I publish it in the system, I would like to immediately read that because I might made a mistake, I need to edit it. But the people that are sitting on the other side, the people that are reading it at home, the news article, it's okay that it takes 2 minutes till they can read the article. So that kind of things, all that kind of things you need to take into account when you're working with data. The part I wanted to say here is you're lucky if you know your boundaries, because that helps you. Any other questions, Brandon, to make it difficult for me? Actually, I ordered his train ticket to Linköping, so I can still cancel it. Talk about functionality first, data last. When you have a microservice that is, and I will say, owning a data source, DB, you don't want to have another microservice owning the same data source, because that means when you are changing the schemas here, or whatever you use as a data source, you have impact in 2 or more data microservices. So you have coupling between the systems. So what you really want to do is one microservice, if needed, one data source. This could be a persistent, this could be a memory. In memory means when you lose your copy, then you need to repopulate it. If you find out that your service domain was too big, then it's very easy to break it into 2. They share this data source. I said before you don't really want to, but you can. Yeah? So you could break this up. They can run your system for a while. Is it working fine? So user designer can be very efficient because you can test this out, often in production. And this you'll just laying around. And then later on, when you're confident, you can start thinking about breaking up that one. Not always possible that easy. Sometimes you need to think about it, but it gives you the possibility. If you look at the other one, if you have 2 microservices and you found out they were too small, and again, I said before, experiment. Remember on the first slide, or no, it was not the first slide, the 4th slide, we said something like, it allows you to, wait, I need to go back. It allows the architecture of an individual service to merge through continuous refactoring. Because microservice allows you to do that, it's very easy to merge those 2 together. Your published API, you need to be careful with that. But you can make one out of it. You don't even have to put the database together. You keep them. You can have 2 different data sources here. One could be an SQL or a SQL database. The other one could be just a flat file if you need to. No problem. I copied the slide in here as an intro into why it is so difficult to change the schema of a database into a microservice. Because in a monolith, I bring down the monolith, stop it, I do some operations, alter table, blah, 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 on my database. I upload a new version of my monolith, and it starts running with the new database. That's how simple it is. You have to bring down the system down. There are smarter ways to do it, but this is mostly the easiest way forward. In microservice, you don't want to do that, and we definitely don't want to do that. We don't want to have customers that don't get their fire alarm answered because we just wanted to rename a table. Huh? But in order to get there, I copied this slide in here. If you have microservice, you can have 2 instances of the same microservice in your system or more. So instance is just a copy running somewhere else. And the load balancer is just balancing the load round robin in this example. So what do you do normally with introducing? What could you do if you want to introduce a new microservice? You just introduce the new version. As long as the API is backwards compatible, you could add new functionality, you can fix things, but you just introduce a new one. And what you do then is you can monitor that one. You say to the load balancer, only 1% of the traffic goes there. But you get real life data there. And you can see, does everything work? And if it works, you say great, and you tell the load balancer to put 33% of the traffic there. So it allows you to test in production. But it also means that if something is wrong, you can just remove that directly. Sounds really smart, is it? But now remember, when you do something with your database down here, they all write into the same database. And if you make a change in a database, you have a problem. You can't do this anymore. You want to do that. I just go further on this. I come back to the database here. You can remove the new version, and this way you can remove very easy the old ones, because you can always remove the new one if something is not working, and you just put in a new instance if you want to increase the capacity. This is really nice with microservices. But what does it mean for databases? Let's say you can optimize this a little bit, but let's say that I want to use that mechanism I showed before. I'm not saying you should do it that way, but I say let's assume you do it that way. Yeah. What happens if you want to just rename the column into a relational database? You have your old version running, then you alter the table and add a column. Let's say the old one was cats, but it turned out that that's a really you'd find out that were not really cats because they say wow wow. So you would like to call this table dogs. But you can't just rename it because your old version of your microservice doesn't write or read to the docs table. So you add a column. I hope your design was that way that your old version could handle that, an extra column. If it couldn't, you will have to make first a new version that can. Then you introduce a new microservice or new code that is reading from the old column and writing to the new column. So it is reading from cats and writing to cats and dogs. Because it can't trust the dogs column because old code was only writing to the cats column. Yeah? And you do that because maybe you did something wrong and you want to remove the new version. So you always need to come back. Once you have done that, all your microservices are replaced by the new one. You copy the datum from the cats column to the dogs column. Because there might be some old data you haven't changed, so you need to copy that from the cats to the dogs. Remember, we're still reading from the cats column. Then you create new code that can read and write from the dogs column. Because you're now sure that all the data is migrated to the new column. There are some optimizations, blah, blah, blah. I just want to show that if you always want to be able to roll back what you do, and you want to have continuous performance, so you don't want to bring down your system, yeah, there are multiple steps. It makes it much more complex. And that's why it is also really hard to change your data domain. Not only because your microservices needs to be rewritten, etc., but also because it's not trivial to just make these changes. Now imagine that this was a little bit more complex, where you're merging two columns into one, or breaking it up, or doing more complex things, or reallocating data over different tables. So microservice makes the organization much more efficient, but there are a number of fallbacks. So my mantra for today was, don't forget why you're doing it. You remember why? More efficient organization, agile. No, I forgot it. Help me, what was my second one? That was my third one. Yeah? Oh, now I hate why I have these animations. Dare to make mistakes. I didn't talk much about that, but remember, monolith, mistake, problems there. Microservice, go down here. If you do it smart, it only affects a small part of your customers. You can take it out really quickly. And it is just really small code, so you can rewrite it. You can easily fix it. In a current situation, if an emergency patch needs to be deployed, there are multiple people that need to have a look at it, approve it, etc., etc. And it takes a long time before we do that. And then multiple people need to look at it. In microservices, if you find out there's a mistake here, and you only found it out in production, there's always a difference between production environments and test environments, how much you do your best. You just remove it, and it's done. So microservice allows you to experiment much more. And our designers thought, oh, we would like to try out this one. And now there's a group that wants to start with closure. Oh, it's great, we can try it out. Because it fits, it's isolated. Yeah? So, don't forget why you do it. Dare to make mistakes. And focus initially on the service layer. That's the 3 things that I would like you to remember. One of the things that we have learned, one of the things that I have learned.